Okay, quadratic models using vertex form. Hopefully, the main ideas are starting to get clearer now. When we first started quadratics, it was like, well, how are we going to do this? What are we going to do about that? And then hopefully some of those pieces are coming together for you. But the confusing part might be, now I got a lot of quadratics in my brain. Which one means what? So this lesson is meant to sort of stop for a second and go, wait a minute, what's out there? Then it moves forward algebraically. I'm telling you, the algebra in this lesson is a little more than some of the other lessons in this chapter. So we have seen, we started with standard form. And the quadratics looked like this. And if that looks confusing to you, this is when they look like this. So it's like y equals 2x squared plus 5x minus 3. It was just like that with x squareds and x's and numbers. And we played around with that, and to be honest, we found out it was virtually useless. You could pick out the y-intercept, sort of, but that was about it. It wasn't, that's not a great form. Then we learned about factored form, which was good. It looked like this. Very satisfying. Easy to pick off the zeros. We could get the graphing pattern. It was very nice. It did a lot of great stuff. It sort of looked like this. We did a lot to work with this. I'll just make one up here. It's not meant to be the same one as I just wrote. Not at all. I'm just writing one going, this is what this sort of looked like. And we were very happy with that because we could pick the zeros off like that and the graphing pattern. But we still couldn't really graph it really well. We had the zeros. That was nice. We could do some word problems, but it wasn't complete. Now, vertex form, y equals a x minus h squared plus k. The h is very confusing, but the idea of the h is to let you know that what's in the brackets is actually the opposite of what we're looking for. And it sort of looked like this. I'll make one a little bit different looking, so again, you don't think I'm trying to do the same one over here. Just, this is hard when you first see these A's and R's and S's and H's and K's, and your brain sort of freezes up. So I just give an example over there, like this is what it's going to look like. And hopefully when you look at these ones, like, oh yeah, we've seen those, okay? So we've learned the strength and weakness of those. And actually our time with quadratics is coming, it's not almost done, but we're almost there where we've covered most of the things in quadratics. Today's lesson is, well, if I've given this form, how do I get to this one? If I've given this one, how do I get to that one? How do I switch back and forth between them? Because up till now, I've been mostly, not always, giving you the one you needed for what you were trying to do. Okay, so today's lesson is just trying to talk about how to get from one form to the other. And it's designed as a study page format. It's another one of those notes where don't finish, when I finish teaching, don't take the note, tuck it away in your binder, okay, go, okay, now I'll start the homework. No. Take the note, put it up in the top corner of your desk, and have it right there, and then start your homework, because it has the instructions for how to do these. By test time, do you have to know how to handle all this stuff? Well, yes, but that's not, on homework night, that's not the night to try and be ready for the test. That's the night to say, can I do this on my own? Yes? More time here? Does this all look sort of familiar? Yes? It's taken some time. That's the only weakness in the way we're teaching it. When we take a lot of time like this to slowly explain quadratics, you might be like in the background of your head going, I don't know if I really remember now, weeks later, what standard form was all about. Here's the instructions. How to rewrite the equation of a parabola from vertex into standard. And I'll do the instructions last. Sometimes when I read the instructions, it messes with people's brains. I'll just write this out and see if I can get it to standard form, and then we'll see if I followed the instructions, okay? So you have this. Y equals 2 bracket x plus 1 squared minus 18. And one way to remember what standard form is, standard form doesn't have any brackets in it. You've got to get rid of the brackets. So to be able to get rid of the brackets for this, I look at that x plus 1 squared, and I put it into what it's actually saying. X plus 1 squared is x plus 1 times x plus 1. Critical step, so I'm going to put an exclamation mark there going, you got to remember to do that. You can't just square the x and square the 1. That would be nice if that worked. That would make it easy. But you've got to use FOIL here. I've given away the next step already. X plus 1 times x plus 1. I can FOIL that all out. So what I get is x squared plus 1x plus 1x plus 1. Those are all 1s. And that makes this question a little easier. Or maybe it's harder. With all the 1s there, is it confusing? And then you collect those up. You've been pretty good at FOIL. I'm not too worried about FOIL. Anything that goes wrong with FOIL is usually some little mistake. You've seen me make those mistakes on the board where you go, oh, I forgot the negative there. You know, we don't get too down about that. Even if it's on a test and costs us a mark, you're like, okay, yeah, I got to practice more, but I'm not going to get all upset about one little mistake. Then what do you see? Remember, my goal to get to standard form is to get rid of all the brackets. I didn't accomplish that yet. By going x plus 1 times x plus 1, I FOILed that all out. Life's way better. But I still got one more distribution to go. The old kind of distribution, which is just arrow this 2 into everything. Multiply everything by 2. And then collect like terms. Just letting everybody process that for a second. Then I'm hoping for some questions. I really am. Because I did that fairly fast on purpose to get the idea across. Because some of your algebra is very strong now, so that all you need is the idea. Give me the idea what I have to accomplish. But please, who's got questions about what I did there? Oh, I thought I saw a hand. Did I not see a hand? I'll wait. I'll let you think about it. Decide. Is it okay now? Notice I FOILed first. I didn't multiply the 2 in. I think that's less error prone. I think you'll make less errors if you take care of the FOIL first and then multiply by the 2 at the end. You don't have to. I could have multiplied the 2 into the first bracket and then FOILed out with that, but then I got those 2's all in there. I think it makes it a little more difficult than you have to. Let's check the instructions and see if the instructions say what I did. Rewrite x minus h squared as x minus h times x minus h. Key, let me put an exclamation mark there. I might even red highlight that. I nominate that as the #1 error in this chapter that people make, is forgetting to take a squared set of brackets and write it out as 2 brackets and FOIL it out. Expand the brackets using FOIL. Hopefully that's getting to be old news. And then multiply the a value by the expanded bracket. So I took that 2 and multiplied it in, and then I just collect like terms. Most people like this one. Yeah? Like, I can do that. But you should be like, why do I want to do that? Is there any reason why I would want to do that? And the answer is, only if they told me to. Standard form's not better. Vertex form is better, usually. So unless there's something else you're trying to accomplish, leave it in vertex form. What does it accomplish? Now it could be factored to find the zeros. Yeah, maybe. So let's not completely write off standard form. But you have questions. Do you have questions? Do you need more time? Oh, I'm looking down. He's copying. I'm like, does he need more time? No, he's moved on to the next one. He's like, oh, like I got this. Let me try the next one. Next one says, to rewrite vertex, to rewrite vertex form given the vertex. We did these yesterday. There's the instructions, but I'm going to teach the opposite way again. I'm not going to read the instructions and have your brain muddle up with what do these instructions mean. I'm going to do it, and then I'll come back and read it and see if the instructions match what I did. Here's what you were doing yesterday. We can do these. I didn't need a separate set of instructions here, but I put it in there so it's all in one booklet for you, yeah? Or all in one page for you. Determine the equation of the parabola in vertex form. It's got the vertex there, yeah? Hopefully. Did your homework. Hey, you look at this in a vertex. I'm already home free. I can, okay, do what I said though. Write this, y equals a, and I write capital A's. You don't have to write capital A's. Most people don't. But my little a's look like 9s, and it messes students up. So I'll write a big A. X minus h squared plus k. And just like we did with y equals mx plus b, then we go, is anything given? Can I just pick off some of this stuff? And the answer is a big yes. Because I've got the vertex. What is the vertex? 2, 4. I think it's awfully helpful to write it right on your graph. So then, without getting hung up in the h's and k's, you don't have to. Can you write this for me? A. We don't know the A yet. You're like, but we have enough experience, hopefully. You did the homework, you have enough experience, like, I'm not worried about the A. I'll get the A in a minute. What's in here? X minus 2 plus 4. Again, she went minus 2. I don't know if she thought about H and went, oh, that means the H is 2, so I go X minus 2. I don't know if she thought about that. She went, if it's positive 2, this one's negative 2. Which way do you think of it? The second way. That's most people with quadratics. Most people, I know you put minus H in there and you're trying to help me, but I don't know if it actually helps me. I just look and go, if this is plus 2, it's negative 2 in the brackets. And more of that to come. More of that to come in grade 11 where you find out what's in the brackets is the opposite. So it's a good way to think about it. All right then, that's a pretty good start. Like we need to know A, H, and K, and in one step I knocked down H and K. And then here's been something we've been working on all the way since grade 9. Sub and solve. The 11s call it sub and solve. Ooh, we'll just sub and solve, they say. Because they know, okay, sub in 2, 4. And this is one of those algebraic situations. I'm not 2, 4. Wrong point. 2, 4 is not going to accomplish what I want. I already used 2, 4. I got to use a different point. Sub in 3, 1. I got carried away with my little story there about grade 11s. Sub in 3, 1. And this looks like trouble. Most people, or sorry, not most people. Some people stop there and go, oh, now I got to solve for A. It's never as bad as it looks. We got all the numbers. Future physics and chemistry people. When you get an equation where you know everything but one value, you're just isolating that. That's actually sort of grade 8, 9 work. I'm not trying to belittle you. I'm just trying to say, this isn't that bad. 3 minus 2, good catch. Again, I get so caught up in my stories as I'm going. I drop numbers there. And again, those of you who make little mistakes sometimes, the little mistakes, you're watching me do it. It happens. Now you got to catch them with checking. Yes? Hopefully you're not talking to somebody while you're doing it like I am. Anyways, 3 minus 2. Yeah, 3 minus 2. And so, again, I argue this isn't as bad as it looks. It looks like a big, scary equation, but it's not. Because what's 3 minus 2? 1. And what's 1 squared? 1. Which made my life a little easier here. Bring that 4 over there. Can I finish in it? Can I fit it in here? I guess I can. Negative 3 equals A. Good. What? Therefore, write the equation. Nothing makes me sadder as your teacher when I have to take a mark off because you had it all there. It makes me sad. You'll see my little tears on your page. And over here I write so with a question mark. I know it's cruel. It's a cruel thing to say. So, yeah, that's what you feel like when you see me marking it. I'm like, so what? And that's not what I'm thinking. I'm thinking, oh, you didn't quite there. It says determine the equation. I've got all the pieces of the equation. Now I put them together and go y equals negative 3x minus 2 squared plus 4. And now I'm looking for a mind reader. What did I do? You saw me backing up. You saw my mouth moving. What was I doing there at the end that you can do to make yourself happy? I took the 3 and I put it in the equation. And I went 3 minus 2 is 1. Squared is 1 times negative 3 is negative 3 plus 4 is 1. You can use your calculator for all that. And I went, oh yeah, it works. If I put in 3, I get 1. I feel pretty good about this situation. Let's see if I did what the instructions said. Did it say? It says to write in vertex form given the vertex. Replace h and k with the x and y values of the vertex. Did that. Yes? From yesterday. Substitute the points, the values for a and x and y. And again, 2 and 3 are separate instructions there. I like them as one instruction. Substitute the values for the points of x and y to solve for the a value. Yeah, that's why you're subbing those in, so you can solve for the a value. And then write the equation at the end. Yes? Otherwise, you'll be sad. I will be sad. Your paper will be all rumpled from my tears on your page. You have questions? Then it says, write this in standard form. Well, let's not wait till tonight. because actually part A was last night's. Part B is today. Try to follow the example I just did in the instructions. Take a few minutes and see if you can take this equation. I'll write it for you here. Y equals negative 3x minus 2 squared plus 4. Look carefully. Don't jump ahead. Take your time. I'll set a nice timer on here. 3 full minutes to try that out. More if you require it. And see if you can take that and put it into standard form. Go slow and careful. Build your confidence. Argue with your friends. Mr. Todd, I wasn't listening when you were teaching. Can you give me the first step so I can start this? Everybody else is doing it. All right, I'll do it. Step 1. With an exclamation mark. There's a mistake people make. There. Now continue on. That was my 3 minutes, but I don't want to rush you. I want you to have time to try this. Did you have time? Who needs more time? Maybe it was too much time, was it? So we expand this out, this x minus 2 brackets, and fix it all up. Do your FOIL, x squared minus 2x minus 2x plus 4. And then there's another plus 4 out here. That's a little confusing. And I get x squared minus 4x plus 4. That was the FOIL part of it. Then multiply by the negative 3. That's the way I like to do it. I think it causes less errors. And so I get y equals negative 3x squared plus 12x minus 12 plus 4. And when I combine that all together, I don't know what happened there, but did you get this? You were happy. You were happy. Yeah? I know some of you are very hard on yourselves. You know who you are. When you do something like that, I just taught it to you 3 minutes ago, and then you just did it, and you got it. You're like, yes, I'm very smart. Yeah, this balances out if you've got those negative voices in your head. Fight back and say, no, no, I'm good. I'm good. I belong here. This is fun. I got it. Questions? It's good. To write from standard form to vertex form. This is wild. I won't read the instructions. I refuse to read the instructions first because I think it'll intimidate you. Okay? So I'm going to approach this a different way. I'm going to teach this just sort of all over the place in an effort for you to see the big idea. Then we'll read the instructions. This says get it from factored form to vertex form. This is for real, friends. Reach down. Not just we talked about do your mental seatbelt up and go, okay, this is going to be good. I better do my seatbelt up. This is like full on. What's that thing called when you go on the Behemoth or the Vortex? Those two big roller coasters. The big shoulder bar. It comes down. The big metal shoulder bar, and then they also do a seatbelt up in the front. And they come and they check it on everybody like, okay, I hope it's good. Good luck. Hopefully I'll see you in 2 minutes. Yeah? That's this one. Get ready. Here's my, you got a plan? What's the plan? Oh, yeah. Let's factor this thing. I don't know how I'm going to get to vertex form. Let's pretend this is on the test. You're like, I don't know what to do. I don't know how to get it to vertex form. But I'll do what Mr. Todd said. I'll factor this thing and see what I can do. We'll see what I can find. Maybe he'll give me some part marks. So you common factor the -3. And we've learned that if the first one's negative, take the negative with you. I apologize to those of you I messed up a little bit. And everybody took the negative always. No. Only take the negative if the first one's negative. So I get x squared minus 4x minus 5. Well, let's just double check that. -3x squared plus 12x plus 15. I literally, you saw me do it. I distributed to make sure. Now what? You could decomp. This one, decomp is overkill. I see some of you on your assignments and on your tests are using decomp all the time. That's fine. But you might reel back now and go, hey, if that coefficient is 1, then I don't need to go all through the decomp. All I need to do is go, what numbers multiply to -5, but add to -4? -5 and 1. And if you're over here still going, okay, what multiplies -5 with 1 and -5, and -1 and 5, and you're making a little list and using that to decide, that's great. Lots of calculus students still do that. Write those notes out. -5, +1. Yes, thank you. Good. We're still not getting vertex form, by the way, and you might get frustrated, but you have to have a little faith and go, okay, well, what else can I find? Now that I have this in factored form, what's easy to find? Find the zeros. Find zeros. Which again, you might be like, I don't know if this is going to work. I don't see the whole plan. Maybe some of you are peeking at the plan up above. Maybe you're better than I give you credit for, and you can read that and go, I know exactly what's going to happen here. And I get the zeros, x equals 5 or x equals -1. Well, I'm learning lots of things about this quadratic or this parabola. I'm not yet ready to do vertex form. But what was the next thing once we had the 2 zeros? What was the next thing we did? Again and again and again. And you're like, why is he torturing us with this again and again? For this moment to go, I can do this. Ellie? What's that? Yeah, find the x value of the vertex. And for the first time, your eyes sort of light up and you go, wait a minute. Maybe I'm onto something here. Maybe this will get the vertex. Sometimes called the axis of symmetry. Yes? But again, I kept writing xv for this moment. Yeah? So you go, oh yeah, x value of the vertex. 5 plus -1 over 2. This went well on the test. Many people, even if they got this wrong, it was just the positive negatives messed them up or something like that. Not a big deal. You can't be too hard on yourselves when that happens. You had the plan. X equals 2. Then what was the last thing we did? Once we had that x value of 2 of the vertex, what did we use it for? Ellie again. Sub it in to get the y value of the vertex. And I'm running out of space here, so I'm going to have to go over here. Sub x equals 2 into, well, you can sub it into your factored form. You can sub it into the original. You should get the same answer either way. A lot of people were subbing it into the factored form, and so that's what I'll do. But it actually doesn't matter. Either equation should give the same answer. So I'll into y. So I used y equals, yeah, actually we learned that from substitution elimination, right? When you go to back sub, you have some choices of where you sub it. And so I get y equals negative 3, bracket 2 minus 5, bracket 2 plus 1, negative 3 times negative 3 times 3, I get 27. I can't resist. In my head, I'm subbing it into the other one to see if it works. Negative 12 plus 24 is 12 plus 2. It works, yeah? Makes me happy. Makes me feel good. So when you have time, I know some tests are a rush, but other times you're like, oh, I'll just sub this in to make sure it works. So I've got the vertex. And maybe at that point in the algebra, you're like, okay, what was I trying to do here? What was this question asking me to do? And then you look back and go, oh, I want it in vertex form. I got it. I got a chance. Yes? 2. 2. What's that? Isn't what 2? Something is 2. What is 2? Oh, yes, good. Having that kind of day. That's what she meant by 2. I thought you were a step ahead of me. You were just saying, oh, that's supposed to be a 2 much shot. Vertex was 2. I literally wrote it and then didn't write it there. Yeah? Again, you're seeing me do it. I'm not doing it on purpose. After some of your stress about little mistakes, it would have been tempting to go up there and do that and make a bunch of little mistakes. Go, see, it's no big deal. It is no big deal. We got a long way to go here. 10, 11, 12, calculus, university. Even if you're not taking all those math courses, you can't get derailed by little mistakes as far as getting all upset about them. Anyways, vertex 227. Back. I was trying to find vertex form. Now I can't do it. Therefore, y equals ax minus h squared plus k. After all that work, I can now write y equals ax minus 2 squared plus 27. I know some of you, I was just in my calculus class, and I noticed that I think it's broken through. We're past the 60% mark in my calculus class as far as how many people are using electronic stuff to take notes. iPads, Lenovo 2-in-1s, Samsung, actually taking the notes. If you first go to do it, take notes electronically, it'll be slower. You feel like you can't keep up. And then you'll get faster. The electronic people are faster in calculus than the other people. And all their notes are on one screen. They walk out of here without it. Instead of a big binder and a notebook, they walk out of here with an iPad. They take it to the next class. Pretty exciting stuff. Now, you don't have to do that. You're not going to learn more because you do it that way. It's not an educational disadvantage to use paper. I'm just saying, if you decide to make that move, you'll see that there's going to be a lot of people around that do the same thing. Yeah? Why did I say that? Oh, I said that so I can do this. Watch this. Here's what iPad people do all the time, or electronic people all the time. They go, I ran out of space there. Just a second. Whoop. Blink. Bleep. Whoop. Hey, stop that. More space. Now I can finish this off. What's the finish off step? Sub and solve. It's got the phrase now. You ready? Yeah? This is a great school. Right now I just say, hey, now that you got that phrase sub and solve, get your stuff and get out of here. Come back in September. Sub and solve. One of the big lessons of grade 10. Sub and solve. So sub in. What point am I going to use? Subbing in the vertex won't help. Watch what happens if I sub in 2. I sub in 2 to here. I get 0. 0 times a is 0, and I can't find a. This is vertex form. Subbing the vertex into vertex form doesn't give me the 0. Or doesn't give me the a value. What should I sub in? A 0. I heard someone say it. Peter said it. A 0, one of these points over here. There they were. 5, 0 is what I chose to sub in. Negative 1, 0 will work as well, but why not use a positive as we're doing it. Because I had multiple points in this question. If you see something else, get ready. I'm gonna solve for this, and then hopefully there's a big aha. You got the big aha? Ready? Yeah, okay, here we go. Sub in 5, 0. So I go y equals a 5 minus 2 squared plus 27. Actually, that's a 0, isn't it? Get ready for a big O. So I subbed in 5, 0. And I get 0 equals a 3 squared plus 27. Take this over there. 0 equals 9a plus 27. Negative 27 equals 9a. Divide by 9. I get a equals negative 3. Whew! A equals negative 3. Good. Are you ready? You already knew a was negative 3. At the very start of the question, we already knew a. So this long procedure, you're like, oh, this procedure is crazy. Yeah, well, that's true, but with a little experience, there is no reason to do this step here. You already had the a. I'm not saying don't do it. I'm just saying it is possible to have seen through this situation. And right there, already go y, therefore, y equals negative 3x minus 2 squared plus 27. I knew a when this question started. I didn't need to solve for a at the end. It's good? Confused by something I see in your note. Oh, it's after. I see. Yes. I put it all on one page on the next page for you. So that's what my last page is. So if you're like, okay, I mostly get what's going on here. All I need is a page that reminds me when I go to do this homework. And that's what your next page is. It doesn't want to go to that page. It's fighting with me. Yes? Here's the summary of what I did. If you want to go from vertex to standard, we do that double distribution thing. First the FOIL, then multiply by the number up front. If you want to go from standard to factored, you just factor the standard form. If you want to go from factored to vertex, then you got to solve for the zeros, solve for the axis symmetry, sub that in. That was the one I did last. Mr. Todd, is there a way to go from standard straight to vertex without going around the whole world here? The answer is yes, but it is quite algebraically difficult. And we'll do it as the first lesson of next chapter. Yeah. For now, you focus on this. Look at how many questions. 7, 9, 10, 15. That's friendly. Doesn't that seem friendly? You're like, I'll find out if it's friendly when I get there and see how many A, B, C, D, E, F, G, H's there is, yeah?